Hello students. In the previous lecture, we saw the formulae of basic trigonometric function. Now in this lecture, we see actual problems of inverse trigonometric function. Find dy by dx for the following. Y is equal to sine inverse of cos x. In this problem, outer function is sine inverse, inner function is cos. Sine, we know that sine inverse sine are inverse operators of each other, they are cancelled to each other. Therefore we change this cos as sine, cos x as sine pi by 2 minus x, cos x sine pi by 2 minus x. Instead of 90 degree we use radian angle, that is pi by 2. Cos x is equal to sine pi by 2 minus x. Now sine inverse sine get cancelled, sine inverse sine get cancelled. Remaining term is pi by 2 minus x. Now differentiate with respect to x, derivative of y with respect to x, dy by dx. Derivative of pi by 2 is 0. Derivative of pi by 2. Pi by 2 means constant term. Pi by 2 means here value of pi is 3.142. If it is in angle, then it is 90 degree. Outside the angle, value of pi is 22 by 7 or 3.142 divided by 2 is the constant. Derivative of constant is equal to 0. Therefore derivative of pi by 2 0, derivative of x is equal to 1. Now 0 minus 1 is minus 1. Therefore dy by dx is equal to minus 1. We use the formula cos x is equal to sine pi by 2 minus x for cancellation of sine inverse and sine. Now next one, y is equal to cos inverse of 1 minus 2 sine square x. Y is equal to cos inverse, outer function is cos inverse. We have to make cos inside the bracket. We know that cos 2x 1 minus 2 sine square half, cos 2x 1 minus 2 sine square x. Therefore 1 minus 2 sine square x, we write it as cos 2x. Now cos inverse cos get cancelled, y is equal to 2x. Differentiate with respect to x, derivative of y dy by dx, derivative of kx is equal to k. Instead of 1 minus 2 sine square x, we write cos 2x. Next, y is equal to cos inverse of 2 cos square x minus 1. Now, 2 cos square x minus 1, we have another formula cos 2x 2 cos square half minus 1, cos 2x 2 cos square x minus 1, 2 1. Therefore, instead of 2 cos square x minus 1, we write cos 2x, cos 2x. Cos inverse cos get cancelled, y is equal to 2x. Differentiate with respect to x, derivative of y dy by dx, derivative of kx is equal to k. Derivative of 2x is equal to 2. Y is equal to tan inverse of root of 1 minus cos 2x upon 1 plus cos 2x. Y is equal to tan inverse of root of, we know that 1 minus cos 2 sine square half, 1 minus cos 2x, 2 sine square half the angle, 2 sine square x, 1 plus cos 2 cos square half, 1 plus cos 2x, 2 cos square half the angle, half of 2x is x. Now 2 and 2 get cancelled in numerator and denominator. Remaining is a root of sine square upon cos square x means tan square x, sine square by cos square tan square x. Root and square cancel to each other, remaining is tan x. Now tan inverse tan get cancelled, y is equal to x is the remaining function. Therefore differentiate with respect to x, derivative of y dy by dx, derivative of x is equal to 1. Here we use two formulae, 1 minus cos 2 sine square half, that is 2 sine square x, 1 plus cos 2 cos square half, 2 cos square x. Next problem is important one, y is equal to tan inverse of sin x upon 1 plus cos x. Now y is equal to tan inverse of, we know that 1 plus cos 2 cos square half, 1 plus cos 2 cos square half the angle, half of x is x by 2. Now in the denominator angle of cos square is x by 2. Therefore we make the numerator angle also as x by 2. Therefore we use the formula sine angle to sine half angle cos of half angle, sine any angle to sine half of that angle cos of half of that angle, 2 sin x by 2 cos x by 2. Now 2 and 2 get cancelled, 1 cos x by 2 and cos x by 2 get cancelled. Therefore remaining is sin x by 2 upon cos x by 2. X by 2 is in angle, therefore don't cancel 2 in denominator, it is in angle. Sin x by 2 upon cos x by 2, sin theta upon cos theta tan theta, sin x by 2 upon cos x by 2 tan x by 2. Tan inverse tan get cancelled, y is equal to x by 2. Differentiate with respect to x, dy by dx, d by dx of x by 2, in which 1 by 2 is a constant term, taking outside the derivative, d by dx of x. Derivative of x is equal to 1, 1 by 2 into 1 is 1 by 2. Here we use two formulae, 1 plus cos 2 cos square half, 1 plus cos x 2 cos square x by 2, and sine angle 2 sine half angle cos of half angle, sin x 2 sin x by 2 cos of x by 2. Next problem, y is equal to tan inverse of sin x upon 1 minus cos x. Y is equal to tan inverse of, we know that 1 minus cos 2 sin square half, 1 minus cos any angle 2 sin square, half of that angle, half of x is x by 2. Now denominator angle becomes half, therefore we convert numerator angle as half angle. Sin angle 2 sin half angle cos of half angle, 2 sin x by 2 cos of x by 2. Therefore 2 get cancelled. Also sin x by 2 and sin x by 2 get cancelled. Therefore remaining is cos x by 2 upon a sin x by 2, cos x by 2 by sin x by 2. We know that cos x by 2 upon a sin x by 2 is a cot x by 2, cot x by 2. But tan inverse and cot are not cancelled. Therefore convert this cot as tan term. Cot x by 2 is equal to tan pi by 2 minus x by 2. Cot theta tan pi by 2 minus theta. Cot any angle tan pi by 2 minus that angle pi by 2 minus x by 2. Now tan inverse tan get cancelled, y is equal to pi by 2 minus x by 2. Differentiate with respect to x, derivative of y dy by dx, derivative of pi by 2, that is derivative of constant 0. In x by 2, taking 1 by 2 outside, derivative of x is 1. Multiplied 1 by 2 to 1 becomes 1 by 2. Therefore I write directly as 1 by 2. 0 minus 1 by 2 is minus 1 by 2 is the answer. Here we use two formulae, 1 minus cos 2 sin square half and sin angle 2 sin half angle cos of half angle. Thank you students.